Well, I'll tell you a couple of my dreams I have if I can one day reach those goals. One of my dreams is to put together self-sustaining energy or perpetual motion machine. One of the ideas I'm working on right now is a water power generator. Just trying to get the money together to try to buy the parts, get it together and run some tests. My other idea is, to try to put it simple, is electric motor spinning a generator. The generator produces enough electricity to power its own electric motor and have extra power to use. Perpetual motion. Now I'm going to throw some numbers at you. This is just off my memory, but you can write it down. You can check my numbers, but it does add up. First, I want to start off of a generator, a 200,000 or 250,000 watt generator. Usually is bolted up to a diesel engine. That diesel engine puts out somewhere around 1,500 RPMs at, I believe it was 800 foot-pounds of torque at about 600 horsepower. So let's just change out the motor to electric motor. So the electric motors I've been looking at are the Tesla motors. There's two electric motors hooked up together. If I remember correctly, I believe it was 700 volts at 700 amps, and it spins at 7,000 RPMs. And it puts out 1,000 horsepower at, I believe it was 900 foot-pounds of torque. But 7,000 RPMs is too fast for that diesel generator. So you run that through a 4-to-1 gear ratio, you're going to decrease the RPMs by 4, so it will spin at about between 1,500 to 1,700 RPMs. But going to a 4-to-1 gear ratio, you are quadrupling the torque. So if you already had 800 foot-pounds of torque, you're going to be putting out over 3,000 some foot-pounds of torque. So in theory, that electric motor will have enough horsepower and torque through that gear reduction to spin that generator. And that generator is putting out somewhere between 200 to 250,000 watts of AC current. You take about, I think it's 20,000 watts through a 240 volt welder. That welder will put out about the 700 volts at 700 amps if you set it up right to run that electric motor. So in theory, you should have between 180 to 195,000 watts to run roughly 10 houses. And I have another idea with a Tesla coil. So to make that simple, a Tesla coil generates a high voltage which goes into a transformer. A transformer drops the voltage down to 120, but it's three-phase of something like 200 amps. And you run that into a DC current and run that through a power inverter back to its own Tesla coil. So you should have about 100 amps to run a house, in theory.